As you know, Thomson, J.J. Thomson has a value of E by mE, electrical discharge by magnetic value, magnitude of or magnetic field value of that specific electron is m by E by mE ratio we have seen so far. So these values are determining going to be combined with the oil drop experiment in the form of mist. So here he has taken in this method an oil drop. Carefully listen here. That is why I have displayed the content whatever required. He has displayed oil droplets in the form of mist. Mist is nothing but small droplets, a kind of vapor like, we can say that vapor like, produced by the atom is here, and it is produced by the atom is here, and were allowed to enter through a tiny holes in the upper plate of electrical condenser. He has taken an electrical condenser and allowed that mist to phase on the surface of electrical condenser. The downward motion of these droplets were viewed when these droplets are moving in the downward position. So that is why I am mentioning here are in the downward position. He has used a telescope to measure their movement, oil drops, in the form of mist. Equipped with a micrometer eyepiece. The telescope is equipped with an eyepiece. Finally, the measuring rate of fall of these droplets. So, the measuring rate of fall of these oil droplets. Millikan was able to measure the mass of oil droplets. So, whenever these oil droplets are moving in the downward position, it's especially the droplets was able to measure, these droplet mass was able to measure, their weight was able to measure by the millikan. Air, whatever present inside the chamber, it was ionized. He has taken a closed chamber. That also I am going to show to you in the diagram in the next slide. While the ionized chamber, the mist particles, oil droplets are moving in the ionized chamber. The passing of beam of X-ray, X-rays are generally passed into this or through it. So electrical charge on these oil droplets, whatever electrical charge is there on the oil droplets, was acquired by the collision with gaseous ions. These droplets are going to interact or collision with oil droplets. The fall of these charged particles, when they were collisioned, which means when they just collision, the small collision was happened. When the collision happened, what happened, you know? Electrical charge on these oil droplets was acquired after collision with the gaseous ions. So, because of this collision only, he has able to observe electrical charge of these oil droplets. The fall of these charged oil droplets can be retarded and accelerated and mode stationary depending upon the charge. So, finally, the polarity and strength of the voltage. So, he has measured the polarity, and polarity is nothing but in which direction it is there, the polarity, poles, specific pole, and movement of the particles towards specific pole. And what will be the strength, the specific strength of the voltage applied to the plate. By careful measuring the effects of electrical field, strength on the motion of oil droplets, Millikan concluded that magnitude, the specific magnitude of electrical charge Q, it is indicated as Q, on the oil droplets, always an integral multiply. It will be always an integral multiply for electrical charge. E is nothing but electrical charge in this experiment, that Q is equivalent to NE, where N equal to 1, 2, 3. Okay. Finally, what is his conclusion? I will explain to you later on. If you see the experiment here, you can see how charge plate, which was mentioned in the closed chamber, which was ionized already, ionized with X-ray beam, X-rays, powerful X-rays are mentioned, and he has seen at the movement of these oil drops in the form of mist with the help of telescope eyepiece, which is mentioned here. So final conclusion is, here it was saying that the experiment for measuring the charge after the collision, Millikan was able to find, the specific value or charge that was there for this specific experiment. The oil droplets contain, or mist contain, charged particles when they exposed to ionization, and when they exposed to ionization contain some of the particles, no, light rays contain some of the particles, no. What are the light rays that are exposed here? X-ray type of light rays. So this X-ray contain charged particles. So the charged particles, when they collisioned, and really I am speaking to you, X-ray particles also contain some of the charged particles, right? Protons, neutrons and electrons. And when they interact to each other after collision, he was able to obtain some of the charged particles, and they were charged because of collision, and the charge of electron is negative. And this experiment says that what is the charge of an electron. So remaining points I will discuss to you in the next class. Thank you. Have a nice day.